All right. So, in this extremely realistic problem that mirrors what actually happens in real life, we have this puck swinging round and round and round on a table that has a hole drilled in the middle of it. There's this other thing just hanging below. And this is ridiculous. Okay, so it's going round and round and round and round, and it's actually holding this thing up. And we have to calculate the speed that keeps this cylinder at rest. So, without further ado, let's draw some free body diagrams because that's actually how circular motion problems work. Um, and of course, the clue that this is circular motion is the fact that the word circle is in the problem. And I'm not being snarky and condescending. When you're in the middle of an exam, your brain will actually like play tricks on you, and you actually may get confused. That's my experience with students. So, like, look for that word circular motion. And so here we've got the mass, little m, and we'll do the free body diagram for that. So we've got the normal force from the table, and then we have the weight of the puck, and then we have this tension force. And then for big M, we have the tension force going up, and we have its weight going down. And you know what? I'm going to write Fg equals little mg here and big mg here just to kind of distinguish it. Now, for the one on the left, the normal force and the weight balance, and that actually doesn't help us very much with the problem. However, the tension force right here is actually an unbalanced force, and the effect of the tension force is it makes the puck accelerate in a circle. Okay, and in fact, because we've been a little rusty on forces, I'm going to make this, just let you know that this is balanced and that this is unbalanced. And we're going to take this one step further. This tension equals the mass of the puck, which is 0.021. And the acceleration, I'm going to do the substitution that since this is circular acceleration, we need to put in v squared over r. And so we don't know what that v is, but I will write v squared and divide it by the radius r, which is 20 centimeters. Careful with that. That's actually 0.2 meters. Now, for the second equation, we have tension balances the weight. These forces are balanced because this thing doesn't move. So we have the tension, tension equals m, which is 0.55, times g, which we're just going to make 10. So the tension is 5.5 newtons. Now look at this. We've got two equations and two unknowns, but we can do a substitution. So I'll say 5.5 newtons equals 0.021 times v squared divided by 0.2. And so we're going to go ahead and simplify here. I'll actually calculate out v. I'll let you do the algebra on your own. But when you solve for v, you should end up getting 7.2 meters per second. And that's it for the fifth problem. We'll take a look at problem number 6 in our last video.